Okay, I just wanted to demonstrate the load capacity of the original Sigma power supply, the one that was in my machine anyhow. I have a SG50 and an SG150, and they both use the exact same power supply. So I suppose it's possible some use different power supplies or lower ratings or whatever, but I had one that I was having a hard time troubleshooting, and as it turns out, if I recall correctly, when the power supply got under load is when it started having issues, and so I had to bench test it. So I just wanted to show what the capacity is of this and how I loaded it up to kind of simulate the power supply being in the game. So this is going to get ugly because we're going to start stacking a lot of things on. So I just wanted to start with just the power supply. Got my meter so I can show you the readings on each of the rails. This power supply, if I remember correctly, I have it marked for my 5, 12, and 24, but if I remember correctly, there's something like a 14 on here, and so I had to mark it because the 12 is only 1 pin and the 24 is only 1 pin, but the 5 volt is 3 pins. Oh, and I think ground is 3 or 4 pins. I don't have those marked. I probably should. So anyway, I just will connect up my power connectors that are connected to my benchtop variable AC. I don't think these need to be isolated, but I pretty much isolate anything that's on the workbench because I don't know what they're isolating and what they're not. Okay, so the primary rail, the one that's really important, is the computer rail, and that's the 5 volt. And so just to give a simple demonstration, I'll turn off this top light. Got a backup power supply going over there, and I'm going to apply the power here, and we can see that we get our 5 volt rail. When I clamp onto ground and I check that rail and I go to voltage, it's a really clean 5 volts, and there is no AC at all whatsoever on these. They're really clean. A lot of power supplies will have a lot of garbage coming through them, and I think somebody mentioned that switching power supplies can often have a lot of what they consider a lot of AC that sneaks through. It's not a lot, not really a ton, but it's measurable. But I didn't measure any AC on this power supply. I don't think on the 5 volt rail I didn't. Okay, I'm gonna turn it off. It's discharged. Okay. Then I'm going to load up. This is going to get weird because I had to find a variety of lamps that simulated different loads. And this is a 12 volt halogen light. So I'm going to actually sneak this clip down here because I can slip it on underneath my meter clip. And that's my 12 volt. So now I will turn this off again. I'm going to power it up. Okay, so I've got my 12 volt light. I got my 5 volt light. My 12 volt rail reads really clean 12 volt. 5 volt is still 5 volt. If I go over to the 12 volt and I switch to AC, I don't get anything. Maybe I'm doing this wrong, but I'm not seeing anything there. Both rails running no problem, really clean, no fluctuation. It just sits there pegged right at 5.08. And I can't remember what this bulb is. Is it a 152 or so? I can't remember where I got it, but it might be a 12 volt bulb. I like to do that because it creates a significant amount of draw on the 5 volt line. And I think actually if I were to grab my 12 volt light, I could stick it on the 5-volt rail, and that 5-volt rail, it's under a significant amount of load, and it's running that bulb. That bulb's getting really warm, so it'll run it. So we've got our 5 and our 12. So that simulates the computer running, and that simulates, I think, bulbs, if I remember right. Okay, light back on, turn off our power. Now, the 24-volt rail. I think it's a 2-amp rail, if I remember correctly. There's my ground, and then there's my load for it. I'll actually leave it off right now because it's a 38-watt incandescent bulb, 38 watts at 120 volt. That equals almost 100 watts at 24 volts. It's a significant amount of load. So we got our 5-volt, we have our 12-volt, and then when I connect my 24-volt line, you may not be able to see that on camera, but it's dimly lighting. And it's holding 23.51. I'm going to take it off. 23.98. So see, it pulls it down a little bit. No AC. No AC. No AC. So again, maybe my meter won't no, actually I've tested power supplies and I've gotten an AC reading on them before. And so no, I know it will pick it up, but the 24-volt rail, yeah, it's quite warm, is all 3 rails are running with this kind of a load right now. And this is a pretty significant amount of load. I figure this bulb right here is probably drawing way more than all the bulbs on the machine. And now that I think about it, I don't know what, I think in the Sigma manual, it talks about which devices are running from which rail. And I can't remember what controls the hopper. There's a hopper controller. But anyway, you can look in the manual and see that. But this is, wow, that's really hot. That's a significant amount of load on all 3 rails, and it held perfectly strong. And the IRF 840 is a little bit warm, but all of the rectifiers, everything else is perfectly cool. Not a bit of heat anywhere. And that's the one, the IRF 840, that on the one that I have that I can't get working, it blows out no matter what I do. So I've got one of these I'm troubleshooting too. Anyway, there you go. That's how I load up one of these power supplies to simulate it in a game environment.